In this video clip, we want to solve the given logarithm functions. The first one is log base 5 to the x equals 3. As I mentioned before, you always want to remember 3 cubed, everyone knows is 8. And the logarithm is the exponent, so you write exponent first. And then the base is always the base. Here is the base for exponential function, and you want to write here as the base of log, and put it right here. So here is just use 2 and 3 to express 8. Here is use 2 and 8 to find 3. Okay? So here is the same thing. You know, 3 is the exponent. Exponent of this base. So if you rewrite it, that will be what? That will be base. The exponent is x. It comes out immediately. That's 5 times 5 times 5, which is 125. So that will be the solution. Quite easy. Now, question 2. Here we are given log base 2 to the x minus 3 is 3. Then based on a similar token, you have a base is the base. Here is the exponent as well. Okay, so you then have a 2 cubed is x minus 3. And then both sides plus 3. What we get will be x equals 8 plus 3, which is 11. Okay, so that will be the answer. Now let's see the third question. The third question was log base 30 to the x squared minus x is 1. Again, rewrite it. Base is the base. You want me, I want you to mark this base. Okay, then you know you should have a 30 is the base to the exponent. This is the exponent. I recommend you to write base in English and exponent in English to mark those places. After you write it, then it will let you recall you can write 30 to the first. Okay, and then equals what? X squared minus x. Alright, then almost comes out. Both sides subtract 30. We shall have a x squared minus x minus 30. Right hand side, you have a 0. Okay, now we know is split negative 6, 30 into negative 6 and 5. 5 times negative 6 is 30, negative. And then you add together, here is negative 1. So you then have the expression will be what? Will be x minus 6, x plus 5 is 0. So in this case, you plug in 6 here, 6 minus 6 is 0. You plug in negative 5 here, so negative 5 plus 5 is 0. So x has two values. One is negative 5, another is 6. Okay, so that will be our solution. Okay, so then we keep going to more examples. Let's see the fourth question. We have 8 plus 8 times natural log x equals 13. Now the strategy here, solution, is to isolate x, leave x alone. Okay, so you subtract 8 on both sides. What do you get? You then get is 8 times natural log x, which is 5. And then you divide 8 on both sides. What you get is natural log x, which is 8 over 5. Natural log means the base is e, is a Euler constant to the x. So you have 5 over 8. And then rewrite this one. Base is the base. And here is exponent. Logarithm is exponent. So what we get will be e is a base to the 5 over 8. 5 over 8 should be right smaller. So let me write e to the 5 over 8, which is x. Okay, so that's another example. Now let's see more examples. Okay, the fifth example is natural log radical x plus 9 equals 3. So we want to find out solution. Solution is to isolate x. How to isolate x? In this case, we want to rewrite natural log as log base e to the x plus 9 equals 3. Again, you want to write to yourself, logarithm is exponent. Here is the base. So you then have x plus 9 is the base e to the exponent. Okay, and then this will come up closer, and then you choose the square on both sides. You should have an x plus 9 on the left. On the right hand side is e to the 3 to the 2 is not addition, it's multiplication. Okay, now you want to do is to isolate x. So you have a x equals e to the 9th power, 6th power minus 9. Okay, that will be our 5th example. Now let's look at 6th example. Okay, we may put here that's e to the x plus 4 equals 6. How to isolate x? What we want to do is choose the log. You have x plus x e to the x plus 4 equals 6. In this case, you want to choose log, natural log. Once you choose the natural log, this one can be brought down to the front. So you should have x plus 4 times the quantity, which is 1, equals natural log 6. Why here is 1, you may wonder. I'll explain to you. This value, let me write one more step for you. So in this way, you will not get confused. So you brought x plus 4 down to the front. So that will be the natural log b. Then equals the, change this to red, natural log 6. Okay, and this value is actually 1. Why is 1? Again, natural log can be written as log base e to the e. Anytime as long as those two numbers are the same, you get 1. For example, log base 2 to the 2 is 1. Log base 3 to the 3 is 1. Why is that? Look, log base 3 to the 3 is 1. The corresponding expression is what? You may want, again, write to yourself, exponent base. So base is 3 to the exponent 1. equals this 3. Everyone knows that. That's why you have all of them. They are all 1. So here, remember, this is 1. Then that comes to be easy then. You shall have what? X plus 4 equals natural log 6. Because 1 times x plus 4 is just x plus 4. And then you subtract 4. You can then isolate x is natural log 6 minus 4. That will be our solution. Alright? Okay. Please review these 6 examples, and then I will see you next time.